Today we will continue with non-inertial frame, that is second type of non-inertial frame, uniformly rotating frame, that is the frame which is rotating about a fixed point with constant or uniform angular velocity. So, let S frame, this S frame is at rest and S dash frame is rotating about O point with constant velocity omega. So, omega is the constant angular velocity, that is uniform angular velocity. So, we know that the position vector of the particle P, when we observe this particle P in two different frames. So, in first frame the distance is r, and with respect to second frame distance is r dash, but magnitude of r and r dash both are same. So, why magnitude? Because the length between this OP or OP dash is same, but the direction is not same. Why? Because in S frame it is distance, simple distance r or r vector. When we turn our face by some angle, then we observe from here this P, then the direction is tilted by some angle. So, direction is tilted. Therefore, direction of r is not equal to direction of r dash. So, magnitude are same, but directions are not same. So, we will deal with the r and velocity. We will find the five parts or five subparts, that is position vector, first one, second one is velocity, third one is acceleration, and fourth one is force. So, we will find these four parameters for non-inertial uniformly rotating frame. Now, we will find velocity. So, what is velocity? We know that here r vector is equal to r dash vector, okay, and we will find velocity. What is velocity? Velocity is the rate of change of displacement. So, we will do derivative or differentiate this equation with respect to t on both sides. We will get dr upon dt equal to dr dash upon dt. Okay. So, what is r and what is r dash? Here r is xi plus yj plus zk. The three components of r vector are these, and three components of r dash vectors are x dash I dash, y dash j dash plus z dash k dash. Okay, these are value of r and r dash. So, it is interesting here I dash, j dash, k dash means directions are also different as compared to I, j, k. In most of the cases directions are same, but the magnitude will change. But in this case both magnitude, that is x become x dash and direction become I to I dash, means direction is also changing. Why? Because frame is rotating, therefore direction is also changing. So, this is a new concept, that is I dash, j dash and k dash. Now, we will put these values in this equation to find the velocity. So, therefore velocity become means d dt of this r is xi plus yj plus zk, and on right hand side d dt of x dash I dash plus y dash j dash plus z dash k dash. Okay. Now, we will solve this dash or the parameters in S dash frame, and on left hand side it will be written as simple velocity. Okay, it is velocity simple or simple v. or this may be written as dr by dt. So, I am writing this as dr by dt because of the r, so there is no any change, therefore, it may be written as dr by dt. So, we will not solve these three components, we will solve only dash components. So, our interest is to solve dash components. So, what is the derivative of on right hand side? So, it is derivative of x dash I dash, derivative of x dash I dash plus derivative of y dash j dash plus derivative of z dash and k dash. Okay. Now, on the right hand side, both x dash and I dash both are variables. In previous articles, we consider mostly I, j, k are constants, but in this case I dash, j dash and k dash are variables, but I, j, k are constants. Therefore, it is variable. So, we may split the derivative of this term is d dt of x dash into I dash plus x dash into d dt of I dash. First derivative first, second term as it is plus derivative of second and first term as it is. Similarly, for y, dy dash upon dt into g dash plus y dash into dg dash upon dt. Similarly, for third, dz dash upon dt into k dash plus z dash as it is d k dash upon dt. So, this is the expansion. Now, we may separate these derivative of I dash, j dash and k dash terms, and we may write it as dx dash upon dt into I dash plus dy dash upon dt into j dash plus dz dash upon dt into k dash. Okay. Now, the second term is second x dash di dash upon dt, y dash dj dash upon dt plus z dash dk dash upon dt. So, these three terms are written collectively, and these again set of three terms, the second part. Now, we may concise it, or this is written as right hand side, this may be written as dx dash upon dt, that is dr dash upon dt, dr dash upon dt or dr dash vector upon dt plus x dash into, what is the value of this di dash upon dt or dj dash upon dt and dk dash upon dt. So, we have not studied such type of derivatives. So, we have studied the derivative of any function. That function may be displacement, velocity, acceleration and something, but in this case it is the derivative of unit vector, unit vector. So, we have not studied the derivative of any unit vector. So, we may solve this unit vector by a different method, that is, where we will solve this di dash upon dt by using formula velocity is equal to omega cross r. We know that this formula is the relation between velocity in translation motion and velocity in angular motion, linear velocity, angular velocity formula. So, you have read this formula in your classes. This velocity will be written as dr upon dt, okay, it is omega cross r. Now, from this equation, it is derivative of r and same r is here. So, we may replace this r r by I dash. So it will become di dash upon dt is equal to omega cross I dash. So in this way, we can find the derivative of I dash with respect to t is equal to omega cross I dash. So we have not actually solved it. We have replaced the value of r with I dash I dash. Similarly, replace this value with j dash on both sides. We will get dj dash is equal to omega cross j dash. And similarly, d k dash upon dt is equal to omega cross k dash. So I have replaced this r dash with I dash, j dash and k dash alternatively. So in this way, these values are d I dash upon dt, d j dash upon dt and d k dash upon dt. These are the values. So we will put as x dash into d I dash upon dt, that is omega cross I dash plus y dash into omega cross j dash plus z dash into omega cross k dash. So in this way, these are the values, three values, and this value is dr dash upon dt, and on the left hand side it is dr upon dt. Now the next step, we may rewrite this equation as dr dash upon dt plus omega cross is common in all three terms, and this is x dash I dash, y dash j dash plus z dash k dash. Okay. So this is, what is this? It is r dash. So it is dr dash upon dt plus omega cross r dash. Okay, this one. So it is dr upon dt. Or we may write it as, this is velocity, dr by dt is a velocity in stationary frame, S frame, and it is a velocity in rotating frame, R frame or S dash frame. So I am writing this R S dash as R. R means rotating, plus I have written this dr by dt with R. Similarly, it is omega cross R, but in rotating. So I have replaced or changed this r dash in simple r, but this r dash is symbolically represented by this rotating r, rotating frame, or this is, it is dr by dt in S frame equal to dr by dt, this one, in rotating frame plus omega cross r in rotating frame. Okay. So this is actually the equation for velocity. So it is velocity in S frame, it is velocity in S dash frame plus something. So this is velocity transformation equation in non-inertial frame. Okay. Now we will find our next part, that is acceleration. Third one is acceleration. So what is acceleration? It is the rate of change of velocity. So we may take the derivative of velocity with respect to time, we may find the acceleration. Okay, acceleration. But again we will apply the same concept, that is the derivative of any function can be done by using this formula as operator. What is this? So this formula is written here. Since, or we know that the equation for velocity is dr upon dt with S frame, dr upon dt with respect to R frame is equal to plus omega cross R. So I am not writing R dash, I am writing r, but with respect to r rotating frame, it means it is r dash, and this r is r, but it is in S frame, so it is r. These are actually r dash, means rotating frame. So this equation is written here, velocity equation. Now first method is to take the derivative of this equation with respect to time on both sides, but we will not do acceleration by taking derivative. We will do derivative by the smart way. Smart way, what is smart way? So we may do the derivative without taking derivative. So the method of replacement method. Replacement. It means we will replace this r from here. That is, it is written as dgt as s dgt of r plus omega cross blank r. Okay, so this is operator. This equation is called equation in operator form. So now we will replace this r with velocity. So we replacement means replace this r vector with velocity in S frame. This one velocity, there are two types of velocities, Vs and Vr. So we will replace this Vs. So I am putting here as Vs. It is Vs. It is Vs. Velocity in S frame. Okay. Now on the left hand side, it is velocity in S frame, and the frame is also S frame. So both are in compatible to each other. Therefore, it is acceleration. So it is acceleration in S frame. Okay. But here there is no compatibility, because inside the term is in S frame, but the outside the frame is R. So there is contradiction, no matching. So we have to change this Vs and Vs, same problem is here, because Vs, but it is with respect to R frame. So we have to either replace this R with S or this S with R. So I will put this Vs on right hand side. We will put Vs as Vr plus omega cross R into R. Okay. So this is the value of Vs. So I will put the value of Vs here. So we will get this A is equal to this is A, and equal to this one d dt of this Vs, that is Vr plus omega cross R frame, and outside is also R frame. Okay, this one. Similarly, omega cross is Vs. Vs means Vr plus omega cross R into R frame, and overall it is also R. So VSR. So by putting these values, we will get the same compatibility, that is inside it is Vr, outside it is also R. So R, these are compatible results. Now we may do the derivative. This will become ddt of Vr, okay, with respect to R frame, plus ddt of omega cross R with R frame, and overall it is also R frame, plus omega cross this one V omega cross Vr plus omega cross R. Yeah, this. Okay. So now it is AS, acceleration S frame is equal to, it is velocity in this, that is AR, acceleration in rotating frame, because Vr it is also R, so derivative velocity is acceleration R frame. Okay, it is omega is constant, so omega cross R, velocity of derivative of R with dt, that is velocity. It will become omega cross velocity in R frame into R plus omega cross velocity R into R frame, because velocity R अलग and R plus last omega cross r in r prime. This is right hand side. So what is this? These two terms are same. It is twice. It is ar plus twice omega cross br. This one, and plus it is omega cross r. So we may skip this r because both are same. So we may skip this r from here. Okay. So I am writing r. I am omitting this r because both frames are incompatible to each other. So it is as. Okay. Or this may be written as ar is equal to as is minus 2 omega cross v, and this term is also on the left hand side become omega cross r. So this is equation for acceleration. It is acceleration in rotating frame, acceleration in S frame, and these two terms. These are fictitious acceleration. Fictitious acceleration. So this is equation for acceleration. Thank you very much.